Now in this lecture I will answer two questions. The first question will find out the area of this green shape using two different methods. And the second question will find out the radius of this semicircle that is inscribed by rectangle ABCD. So we start with the first question. In the drawing we have rectangle ABCD. Side AB of rectangle ABCD equals to 4 units in its length. This is line segment AE, this equals to 1 unit in its length. Inside this rectangle we have triangle, the green triangle BCE. Angle BEC equals to 45 degrees inside. Again, our test is to find out the area of this green shape, the area of the green triangle BEC with angle 45 degrees. So first of all, ABCD is a rectangle, and therefore all those four angles are right angles. We'll define the length of this line segment ED as x. So side AD equals to 1 plus x. We also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABCD, side AB must be equal to the opposite side DC, but AB is 3, therefore the opposite side DC must be also equal to 3 units in its length. Likewise, according to the same rule, in the same rectangle ABCD, side AD must be equal to the opposite side BC. But AD in total equals to 1 plus x, therefore the opposite side BC must be also equal to 1 plus x units in its length. In the next step, we will do a construction, that is to say from point E, we will draw perpendicular on BC. Again, from point E, we will draw perpendicular on side BC of rectangle ABCD. So here, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We will define the touching point of the perpendicular from point E and BC. This point is point M. By doing this construction, we write here the small quadrangle ABME. Inside the small quadrangle ABME, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this 4 pieces angle, in total must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 pieces angle must be equal to 90 degrees in its size. So inside the small quadrangle ABME, we have 4 rectangles, and according to rule 5, any quadrangle that has 4 rectangles must be placed a rectangle if not a square. So we relate to the small quadrangle ABME is a rectangle because it has 4 right angles. Okay, now but we also know that the opposite sides of a rectangle are equal to each other. So then of the ABME, side AB must be equal to the opposite side ME. But AB is 3, therefore the opposite side ME must be also equal to 3 units in its length. We will define the perpendicular ME as edge, evaluation for height. So M equals to edge equals to 3. Actually, EM is the height to the base BC of the green triangle BEC. Therefore, we define 97 EM as edge, that is evaluation for height. This is the height to the base BC. The green triangle BEC. So, in the next step, we will implement the Pythagoras theorem in this upper right triangle BAE. On the upper right triangle BAE, first of all, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle BAE, here by PT is the relation for Pythagoras theorem. In the right triangle BAE, according to the Pythagoras theorem, BE squared, that is the square of the hypotenuse, equals to AB squared plus AE squared. And again, in this upper right triangle BAE, according to the Pythagoras theorem, BE squared, that is the square of the hypotenuse, equals to AB squared plus AE squared. BE is the missing hypotenuse, so we leave it as it is. So it is BE squared equals to AB squared. AB is 3, therefore AB squared is 3 squared, that is 9. Plus AE squared. AE is 1, therefore AE squared is 1 squared, that is 1. So in total, we found out that BE squared equals to 9 plus 1, that is 10. So BE squared equals to 10. Here we'll take a look out of this equation and finally get that the missing hypotenuse BE is equal to the square root of 10 units in its length. So this is the hypotenuse BE, that is equal to the square root of 10 units in its length. In the next step, we will implement the Pythagoras theorem on this right lower triangle EDC. Here by PT is the relation for Pythagoras theorem. So in the right lower triangle EDC, EC squared, that is the square of the hypotenuse, equals to ED squared plus BC squared. But again, in the right lower triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. EC is the missing hypotenuse, so we leave it as it is. So it is EC squared equals to ed squared. Ed is x, therefore ed squared is x squared plus dc squared. Dc is 3, therefore dc squared is 3 squared, that is 9. So in total we found out that ec squared equals to x squared plus 9. Here we will take a root out of this equation and finally get that the missing hypotenuse EC is equal to the square root of x squared plus 9. This is the hypotenuse EC of the right triangle EDC, and it is equal to the square root of x squared plus 9 units in its length. So as you know, EC equals to the square root of x squared plus 9. Our task is to find out the area of the grain shape, this grain shape. This grain shape is actually the grain triangle BEC. So we will find out the area of this grain triangle BEC by using two different methods, and then we get an equation that says that the area of this grain triangle BEC according to the first method of calculation must be equal to the area of the same grain triangle BEC according to the second method of calculation. So according to the first method of calculation, the area of this right triangle BEC, if this grain triangle BEC is equal to the base BC, the base BC times the height ME is equal to H over 2. So again, according to the first method of calculation, the area of this grain triangle BEC equals to the base BC times the height H over 2. BC is x plus 1 times H. H is 3 divided by 2. So in total, according to the question 1, if you found out that the area of the grain triangle BEC equals to x plus 1 times 3 over 2. In the next step, we calculate the area of this grain triangle BEC in a different way. Actually, this is triangle ABC that could be any triangle. The length of side AC equals to B units in its length, side AB equals to A units in its length. The angle between those two sides is this angle theta. So the area of this triangle, triangle ABC, that could be any triangle, equals to the multiplication of the two sides by each other, that is to say A times B, times sinus angle between the two sides, that is theta over 2. And again, the area of this triangle ABC, that could be any triangle, equals to A times B times sinus theta over 2. So we use the new formula in order to find out the area of this great triangle EBC. So according to the new formula, the area of this triangle EBC equals to the multiplication of two sides by each other, that is to say EB times EC, times sinus angle between the two sides, that's actually sinus 45 degrees over 2. So write it down. So according to the second method of calculation, the area of this great triangle EBC equals to multiplication of the two sides by each other, that is associating EB times AC. Times sinus angle between those two sides, that is sinus 45 degrees. Over 2. This equation is the implementation of the new formula in our green triangle BC. So according to the second method, if we found out that the area of this green triangle BEC equals to EB times AC times 45 degrees over 2. So in the next step, we get the equation 3 that says that the area of the green triangle BEC, according to the first method of calculation, must be equal to the area of the green triangle BEC, according to the second method of calculation. And the area of the green triangle BEC according to the first method of calculation equals to x plus 1 times 3 over 2. It must be equal to the area of the same green triangle BEC according to the second method of calculation, and the area of the green triangle BEC according to the second method of calculation equals to EB times AC times sinus 45 degrees over 2. Repeat again. This is equation 3. Equation 3 says that the area of the green triangle BC according to the first method of calculation must be equal to the area of the same green triangle BC according to the second method of calculation. So here we have 2 on both sides of this equation, so 2 will get cancelled. After I cancel 2, in the side of the equation 3 we have to leave x plus 1 times 3, while on the other side of this equation 3 we have EB, we left with EB times EC times sinus 45 degrees. Sinus 45 degrees is square root of 2 over 2. So, according to equation 3, if we found out that 3 times x plus 1 equals to EB times EC times square root of 2 over 2. We already found out that EB equals to the square root of 10 times EC. EC equals to the square root of x squared plus 9. Okay, again, if we found out that 3 times x plus 1 equals to EB square root of 10 times EC square root of x squared plus 9 times square root of 2 over 2. Inside of the equation 3 we have square root of 2 times 2, square root of 10 times square root of 2, that is square root of 20. So in this side of the equation we have 3 times x plus 1 equals to square root of 2, square root of 10 times square root of 2 is square root of 20 times x squared plus 9 over 2. So according to equation 3, we have found out that 3 times x plus 1 equals to, we have square root of 20, we substitute 20 by 4 times 5, so inside the out we have 4 times 5, times square root of x squared plus 9. The square root of 4 is 2, so we take 4 out of the root, and inside the root we left only square root of 5. So here in total, according to equation 3, we can find out that 3 times x plus 1 equals to, again, the square root of 4 is 2, so we take 4 out of the root. So it is 2. Inside the root we left only with 5 times, here we have 2, so we have to copy 2 here. So it is divided by 2 times square root of x squared plus 9. Here we have 2 in the numerator, 2 in the denominator, so 2 get cancelled. So we cancel 2. If we found out that according to equation 3, three times x plus 1 equals to the square root of 5 times the square root of x squared plus 9. So here we will square both sides of this equation, equation 3. And again, let's go into this equation, equation 3. 3 squared is 9 times x plus 1 squared. And it equals to the square root of 5 squared is 5, and the square root of x squared plus 9 squared is x squared plus 9. One because of the fact that the square cancels the root, and we left only with x squared plus 9. So in total we found out that 9 times x plus 1 squared equals to 5 times x squared plus 9. We will open the brackets on both sides of this equation, equation 3. So again, that according to equation 3, this side of equation 3 we have 9 times x plus 1 squared. So it is 9 times x plus 1 squared. X plus 1 squared equals to x squared plus 1 squared, that is 9, plus 2x, plus 2 times x times 1, that is 2x. And it is equals to the other side of the equation, we have 5 times x squared, that is 5x squared, plus 5 times 9 is 45. Here we will open the brackets on this side of this equation, equation 3, and here that according to equation 3, 9 times x squared is 9x squared, plus 9 times 1 is 9, plus you have 2x actually. The square root of x plus 1 squared equals to x squared, and plus 1 squared is 1, plus 2 times x times 1 that is 2x, so here equals to 2x. And 9 times 2x is 18x. And it equals to 5x squared plus 45. Here we subtract 5x squared from this equation, equation 3. So again, this is going into equation 3. Nine x squared minus 5x squared is 4x squared plus 9 plus 18x equals to 45. Here we will subtract 45 from this equation, equation 3, and so again that according to this equation, equation 3, four x squared plus 18x, and we have 9 minus 45 is minus 36 equals to 0. Here we divide this equation by 4. So again that according to this equation, equation 3, four x squared over 4 is x squared plus 18x over 4 is 4.5x, and minus 36 over 4 is minus 9 equals to 0 over 4 is 0. So in total, if you found out that x squared plus 4.5x minus 9 equals to 0. So actually, this is a quadratic equation, and the general formula for a quadratic equation is as follows. Ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation. And x is the variable that we're looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 4.5x minus 9 equals to 0. The variable that we're looking for is x. X is actually the value of approximate ED. In our specific quadratic equation, the coefficient a equals to 1. The coefficient b equals to 4.5. And finally, the coefficient c equals to minus 9. So we have all the data that is needed in order to find out the value of x, that is the value of line 7 DE. You just have to put the data of our specific quadratic equation, to say this data inside this general formula for x, and in this way we find out the value of the values of x. Well, x might have two solutions. So we'll do it now, and we get that x equals to minus b. b is 4.5, and therefore minus b is minus 4.5, plus minus square root of b squared. b is 4.5, and therefore b squared is 4.5 squared, that is 20.25, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is minus 9, so minus 4 times minus 9 is plus 36 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So inside the root we have 20.25 plus 36. So in total, if you found out that x is the left of line segment DE equals to minus 4.5 plus minus, inside the root we have 20.25 plus 36, that is actually 56.35. So inside the root we have 36.25. So inside the root we have left only with 56.25 over 2. So in total, if you found out that x equals to minus 4.5 plus minus the square root of 56.25 is 7.5 divided by 2. So repeat again, in total, if you found out that x equals to minus 4.5 plus minus 7.5 over 2. So here we have two solutions that are possible for x. The first solution for x is as follows. X equals to minus 4.5 minus 7.5 over 2. minus 4.5 minus 7.5 is minus 12 over 2. Minus 12 over 2 is minus 6. So the total according to the first solution for x equals to minus 6. X equals to minus 6. So the division before, x is the length of line segment ED. Again, x is the length of this line segment ED. So x is the length, and therefore it must be a positive number. X can never be equal to minus 6, that is a negative number. So we cancel this solution for x and we take into account only the second solution for x. The second solution for x is as follows. X equals to minus 4.5 plus 7.5 over 2. Minus 4.5 plus 7.5 is 3 over 2. So in total we found out that x equals to 3 over 2, that is 1.5 units in its length. And again we found out that the length of this line segment ED is equal to 1.5 units in its length. So our test is to find out the area of this green shape. The green shape is actually the green triangle in BC. Okay, again, our task is to find out the area of the green shape. The green shape is actually the green triangle ABC, so our task is to find out the area of the green triangle ABC. The area of the triangle equals to the base of the triangle times the height over 2. Again, the base of any triangle equals to the area of any triangle equals to the base of the triangle times the height over 2. So the area of this green triangle ABC must be equal to the base BC. We choose the base as BC. So it is the base, this is BC, times the height. The height is h over 2. So I should found out that the area of the green shape in total equals to the base BC times the height h over 2. BC equals to 1 plus x. Times the height edge, that is 3 over 2. So the area of the green shape in total equals to 1 plus x times 3 over 2. We just right now found out that x equals to 1.5. So, and therefore 1 plus x is 1.1.5, that 1 plus 1.5, that is 2.5 times 3 over 2. 2.5 times 3 is 7.5 over 2. 7.5 over 2 is equal to 3.75 square units in its size. So we found out that the area that we are looking for this question, that is the area of this green shape, is equal to 3.75 square units in its size. So we finished with the first method. The next step I will present to you how to find out the area of this green shape according to the second method. ABCD is a rectangle, therefore all those four angles are right angles. In the next step, we will define this line segment ED as x, that is to say ED equals to x units in itself according to our definition, exactly as we did in the first method. We also know that the opposite sides of a rectangle are equal to each other. So in this rectangle ABCD, side AB must be equal to the opposite side DC. But AB is 3, therefore the opposite side DC must be also equal to 3 units in its length. According to the sum rule, in the sum rectangle ABCD, side AD must be equal to the opposite side BC. But AD is 1 plus x in total, therefore BC must be also equal to opposite side BC must be also equal to x plus 1 units in its length. So if we know BC equals to x plus 1 units in its length. In the next step, we will do a construction. This is to say, from point E, we will draw perpendicular on BC. Again, from point E, we will draw perpendicular on BC. Actually, I repeat on the steps that we have already done in the first method. So actually, this angle equals to 90 degrees on its side, and this angle also equals to 90 degrees on its side according to our construction. We define the touching point of the perpendicular from point P, from point E and BC. This point is point M. By doing this construction, we can deduce the small quadrilateral ABME. Inside this small quadrilateral ABME, we have 1, 2 rectangles. The sum of rectangles is 270 degrees. So 270 degrees plus the size of this four-piece circle in total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this four-piece circle must be equal to 90 degrees in size. So in quadrilateral A, E, and B we have 4 rectangles, and therefore we can write to this quadrilateral A, E, and B as a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in the small rectangle AB and ME, side AB must be equal to the opposite side ME. But AB is 3, therefore the opposite side ME must be also equal to 3 units in its length. We define the length of the perpendicular EM as h, so EM equals to h equals to 3. H is the expression for height. EM is actually the height to the base BC on the green triangle BEC. Again, EM is the height to the base BC of the green triangle BEC. So in the next step, we will define this angle, again AEB as theta. We will focus on this right upper triangle, triangle AEB. The right upper triangle AEB. tangent theta equals to AB over AE. But again, this right triangle AB, tangent theta equals to AB over AE. AB is 3 over AE. A is 1. Three over 1 is 3. So according to equation 1, you have to find out that tangent theta equals to 3. Here we have the trigonometric identity. It states that tangent 45 degrees plus theta equals to 1 plus tangent theta over 1 minus tangent theta. We already found out that tangent theta equals to 3. So we define this trigonometric identity as equation 2. According to equation 2, tangent 45 degrees plus theta equals to 1 plus tangent theta. But tangent theta is 1, so we can substitute tangent theta equals to 3, so we can substitute tangent theta by 3. So in total, in the numerator of this expression, we have 1 plus tangent theta, that is 3, or 1 minus tangent theta. So it is 1 minus tangent theta. Tangent theta is 3. So in total, we found out that tangent 45 degrees plus theta equals to 1 plus 3, that is 4, over 1 minus 3, that is minus 2. 4 over minus 2 is minus 2. So in total, if we found out that according to equation 2, tangents goes to, that's equal to each other. So tangents, according to equation 2, if we found out that tangents 45 degrees plus theta equals to minus 2. This is according to equation 2, while according to equation 1, we already found out that tangent theta equals to 3. This is side AD. It is one side of this rectangle ABCD. So AD is the size of a rectangle. It is absolutely a straight line. So if you focus on the upper side of, if you focus on the right side of the straight line AD at point E, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas from one side of a straight line is equal to 180 degrees. So at the right side of the straight line AD, at point E, the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line AD at point E? We have this angle that is theta, plus this angle that is 45 degrees in size, plus this missing angle, the angle DEC, In total, the sum of those figures must be equal to 180 degrees according to all three. So okay, again we should find out that in the right side of the straight line AD at point D, the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the right side of the straight line AD at point D? We have angle theta, the other angle is 45 degrees, plus this first missing angle, the angle DEC, in total must be equal to 180 degrees according to all three. So here we will subtract theta from 45 degrees from this equation. And you get that the missing angle DEC is equal to 180 degrees minus theta plus 45 degrees. So actually, this is the missing angle DEC. In total, it is equal to 180 degrees minus theta plus 45 degrees in its size, according to all three. In the next step, we'll focus on this right lower triangle, triangle EDC. This right lower triangle, triangle EDC, tangents 180 degrees minus theta plus 45 degrees equals to DC over AD. So it is now the tangents of this angle actually equals to 180 degrees minus theta plus 45 degrees is equal to DC over AD. Okay, again, this right lower triangle, triangle EDC. Tangents 180 degrees minus theta plus 45 degrees equals to DC over AD. DC is 3 or ED is X. So if you found out that tangents tangents 180 degrees minus theta plus 45 degrees is equal to 3 over X. We have another trigonometric identity that says that tangents 180 degrees minus theta equals to minus tangent theta. So as you know, we have the trigonometric identity that says that tangents 180 degrees minus theta equals to minus tangent theta. So according to this trigonometric identity, the value of tangents 180 degrees minus theta plus 45 degrees will be equal to minus tangents theta plus 45 degrees. And again, according to this trigonometric identity, tangents 180 degrees minus theta plus 45 degrees equals to minus tangents theta plus 45 degrees. So we substitute tangents 180 degrees minus theta plus 45 degrees by minus tangents theta plus 45 degrees. This is equation 3. And again, tangents 180 degrees minus theta plus 45 degrees equals to minus tangents theta plus 45 degrees. And is equals to 3 over x. And again, according to question 3, if you found out that minus tangents theta plus 45 degrees equals to 3 over x. But according to equation 2, we already found out that tangents theta plus 45 degrees, tangents 45 degrees plus theta equals to minus 2. We substitute tangents theta plus 45 degrees in this equation by minus 2. And again, that's according to equation 3. We have minus and tangents 45 degrees, tangents theta plus 45 degrees equals to minus 2 according to equation 2. So in total, in this equation 3, we have minus 2. This is equals to 3x. Minus 2 is plus 2. If you don't know that according to equation 3, 2 equals to 3 over x. Here we multiply this equation by x. And finally get that according to equation 3, 2x equals to 3. And again, according to equation 3, we actually found out that 2x equals to 3. Here we will divide this equation by 2. Again, this is according to equation 3. X equals to 3 halves. This is 1.5 units. So if you don't know that x equals to 1.5 units, it is there. Our task is to find out the area of this green shape. So what is the area of the green shape? The area of the green shape, it is actually the area of this green triangle BCE. And again, the area that you are looking for in this question, that is the area of the green shape, is actually the area of the green triangle BCE because of the fact that the green shape is a triangle. It's the area of the green shape equals to the area of the green triangle BCE. And the area of the green triangle BC equals to the base BC times the height edge over 2. BC equals to 1 plus x times the height edge equals to 3 over 2. X equals to 1.5, therefore 1 plus x is 1 plus 1.5, that is 2.5 times 3 over 2. 2.5 times 3 is 7.5, and 7.5 over 2 equals to 3.75 square units in size. And again, if you found out in both methods that the area that we are looking for this question, that is the area of this green shape, in both methods is equal to 3.75 square units in size. So we finished to answer the first question. In the next step, I'll present to the second question, and we'll solve the second question of this lecture. The second question, our task is to find out the radius of this semicircle. And again, our test is to find out the radius of this semicircle that is described by this rectangle ABCD. So in the moment you have a semicircle that is described by this rectangle ABCD. This is line segment QB, which is equals to 1 unit in length. This is line segment PD, this is equals to 2 units in length. Again, our test is to find out the radius of this semicircle that is described by this rectangle ABCD. So, first of all, ABCD is rectangle, therefore all those 4 angles are right angles. In the next step, we define the radius of this semicircle. This point is point O. We define the center of this semicircle. This point is point O, and we define the radius of this semicircle as x. Okay, again, our test is to find out the value of x. This is the radius of the semicircle. Okay. We define the point of tendency of tangent DC with this semicircle. This point is point T. Likewise, we define the point of tendency of tangent BC with this semicircle. This point is point L. In the next step, we will join points Q and T together by a straight line. Point O is the center of the semicircle, point T is the point of the semicircle itself, therefore OT is the radius of the semicircle, is equal to x according to our definition. The radius OT is equal to x, the radius OT is drawn to point T, this is the point of tendency CD with this semicircle. And whenever your radius is drawn to the point of tendency, then tangent DC will be perpendicular to the radius TO. If tangent CD is perpendicular to TO, it means that this angle equals to 90 degrees in its side. And this angle also equals to 90 degrees in its side according to rule 1. In the next step, we will join points O and F together by straight line. Point O is the center of the semicircle, point L is the point of the semicircle itself, therefore OL is the radius of this semicircle, is equals to x. The radius OL is equals to x, the radius OL is drawn to point L, that is the point of tendency of tangent BC with this semicircle. And whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius LO. If BC is perpendicular to LO, it means that this angle equals to 90 degrees in size. And this angle also equals to 90 degrees inside according to the same rule 1. So in total, inside the lower quadrangle, the lower small quadrangle OLCT, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, the must be equal to 360 degrees according to the rule that said that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So, inside quadrangle OLCT, we have 4 rectangles, and so therefore, we can relate to quadrangle OLCT is a rectangle. According to rule 5, that said that any quadrangle that has 4 rectangles must be a rectangle plus a square. So, we relate to the small quadrangle OLCT is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So, the small rectangle OLCT, side OT must be equal to the opposite side LC. But OT equals to x, therefore the opposite side LC must be also equal to x units in its name. Likewise, according to the same rule, in the same rectangle OLCT, side OL must be equal to the opposite side CT, but OL is x, therefore the opposite side CT must be also equal to x units in its name. So in total, we found out that quadrangle OLCT is not a rectangle, but a square. Why? Because of the fact that all of its sides are equal to each other. Each side equals to x. So you know, this is quadrangle OLCT, this is a square. In the next step, we will do a construction, that is to say, from point O, that is the center of this semicircle, we will do perpendicular on AB. Again, from point O, we will do perpendicular on side AB, or perpendicular ABCD. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point O and AB. This point is point Z. By doing this construction, we can do the upper small quadrangle ZBLO. Inside this small quadrangle ZBLO, we have 1, 2 feathers, and therefore this fourth missing angle must be equal to 90 degrees inside according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. So in quadrangle ZBLO we have 4 rectangles, and therefore we can relate to this quadrangle ZBLO is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in this form of rectangle ZBLO, side OL must be equal to the opposite side ZB. But OL is x, therefore the opposite side ZB must be also equal to x units in its length. Write it down. This is the opposite side ZB, for rectangle ZBLO. It must be equal to x units in its length. What is the length of this missing 97 ZQ? From the dominant, it's very easy to see that ZQ in total equals to ZB minus QB. And again, ZQ equals to ZB minus QB. So ZQ in total equals to ZB is x, minus QB is 1. So in total, we found out that the length of this missing 97 ZQ equals to x minus 1 units in its length. In the next step, we will do another construction. That is to say, from point O, that is the center of this semicircle, we will do perpendicular on AD. And from point O, we will do perpendicular on AD, side AD of this rectangle ABCD. So actually, this angle equals to 90 degrees inside, and this angle also equals to 90 degrees inside according to our construction. We define the touching point of the perpendicular from point O and AD. This point is point G. By doing this construction, we get the upper quadrilateral AZ OG. Inside this quadrilateral AZOG, we have 2 vertices. Therefore, this fourth missing must be equal to 90 degrees inside. According to the sum rule, it said that the sum of the areas in any quadrilateral is equal to 360 degrees. So by doing this construction, we created another quadrilateral, that is the lower quadrilateral, GOTD. Inside this lower quadrilateral GOTD, we have 2 vertices, and therefore this fourth missing must be equal to 90 degrees inside according to the sum rule. It said that the sum of the areas in any quadrilateral is equal to 360 degrees. So inside the quadrilateral GOTD, we have 4 degrees, and therefore can relate to this quadrilateral as a rectangle. This is a rectangle, and this is also a rectangle. So it has 4 rectangles. We know that the opposite sides of a rectangle are equal to each other. So the opposite sides of the lower rectangle GOTD must be equal to each other. But OT is x, therefore the opposite side GD must be also equal to x units in its length. GD in total equals to x. So what is the length of this missing 97 GP? From the dominant, it's very easy to see that GP in total equals to GD minus PD. Again, GP equals to GD minus PD. So in the number, we found out that the missing 97 GP in total is equal to GD minus PD. So the missing 97 GP in total equals to GD is x minus PD is 2 according to what is given in the question. So in total, GP equals to x minus 2 units in its length. This is the missing line segment GP. This is equals to x plus 2 units in its length. This is the big angle GOL. The size of the big angle GOL equals to 90 degrees plus 90 degrees is 180 degrees. So the big angle GOL equals to 180 degrees in its size. So it is known. But we know that any angle is equal to 180 degrees in size, it is defined as a straight line. Therefore, line segment GOL is a straight line. Line segment GOL is a straight line because angle GOL equals to 180 degrees. If line segment GOL is a straight line, it means that GL must be also a straight line. Line segment GL is also a straight line. And therefore, this is shape ABLG. Shape ABLG has 4 sides. 1, 2, 3, 4. So it is known. Shape ABLG has 4 sides. I read again. The upper shape ABLG is 4 sides, and therefore it is a quadrilateral. Shape AP is a quadrilateral because it has 4 sides. So in the upper quadrilateral ABLG, we have 4 right angles. 1, 2, 3, 4. Again, quadrilateral ABLG has 4 right angles. And therefore, we can relate to quadrilateral ABLG as a right angle. And again, this is quadrilateral ABLG that has 4 angles, and therefore it is a rectangle. But we also know that the opposite sides of a rectangle are parallel to each other. Okay, so in this rectangle ABLG, side AB is parallel to the opposite side LG. Rectangle ABLG, side AB is parallel to opposite sides, to the opposite side LG. And therefore, we can implement rule 10 in our drawing because of the fact that if quadrilateral ABLG side AB is parallel to the opposite side LG, we can implement here rule 10. So please click on rule 10. According to Rule 10, corresponding angles between parallel lines are equal to each other. So in the drawing we have line A that is parallel to line B. This is the line C, this is a transversal. That is to say, it cuts those two parallels and those 2 points. Those 2 angles are defined as corresponding angles and are located between the parallels A and B, therefore they are equal to each other in their sizes. Then you can see that each of them equals to 1, and therefore they are equal to each other. Likewise, those 2 angles are also defined as corresponding angles and they are located between the same parallels A and B, therefore they must be equal to each other in their sizes according to this Rule 10. You see that both of them are equal to 2 and therefore they are equal to each other in their sizes. So according to this Rule 10, corresponding angles between parallels are equal to each other. So we can implement Rule 10 in our drawing. In our drawing, AB is parallel to GL. AB is parallel to GL. AB is parallel to LG. And this is the transversal QP that cuts those 2 parallels in G. Therefore, all the requirements of Rule 10 are satisfied. Therefore, we can implement Rule 10 in our drawing. Those 2 angles are defined as corresponding angles and they are located between the parallels AB and GL. Therefore, they must be equal to each other in their sizes according to Rule 10. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha because they are equal to each other according to Rule 10. Okay. In the next step we will focus on the upper right triangle OZO. In this upper right triangle OZO, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, according to the same rule, the lower triangle OGP, this angle equals to alpha. This angle equals to 90 degrees, therefore this first angle must be equal to 90 degrees minus alpha according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we will prove that this is the green right triangle OZQ. That this green upper right triangle OZQ can point to this right lower green triangle GOP. Then again, we prove that those 2 right green triangles can point to each other according to side angle rule. So like in order to prove that this is the upper green triangle ZQO. That it can point to this right or lower green triangle OGP. So, why those 2 green triangles can go into each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. So actually this is angle ZQO. In the right upper great angle ZOQ, and this is equal to this angle, the angle GOP. In the right lower triangle GPO. And again, if you found out that in the right upper triangle ZQO, angle ZQO equals to angle GOP. They are both equal to alpha, and therefore they are equal to each other. What is the definition of line segment QO? Line segment QO starts from point O, that is the center of the semicircle, and ends at point O, that is the point of the semicircle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this semicircle, because we actually see itself according to our definition. Likewise, what is the definition of line segment OP? Line segment OP starts from point O, that is the center of the semicircle, and ends at point P, that is the point of the semicircle itself. Therefore, OP is the radius of the semicircle, equals to X. So sine OQ of the green upper right triangle ZQO equals to sine OP of the right green triangle GOP. Now above the area of the circle, that is equals to X, and therefore they are equal to each other. And again, if you want to know that sine OQ of the upper green triangle ZQO is equal to sine OP of the right lower triangle OAP. Now above the area of the circle, that is equal to X, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees on alpha, and therefore they are equal to each other. So actually this is angle ZOQ. In the upper right green triangle ZQO, and it's equal to this angle, this angle GPO. In the right triangle GOP. Repeat again, we should found out that angle ZOQ in the upper right green triangle ZQO is equal to angle GPO in the right lower green triangle GPO. They are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So if we prove that the upper green triangle ZQO congruent, this is the same congruent to the right lower green triangle OGP, according to angle sine angle 1. Repeat again. We actually prove that those two right green triangles can go into each other according to angle sine angle 1. That is to say, we actually prove that those two angles and the side that is included between those two angles, that is actually the side QO, again, those two angles and the side that is included between those two angles, that is actually side QO. This green upper right triangle ZOQ are corresponding equal to those two angles, and the side that is included between those two angles, that is actually side OP, in the green upper lower triangle GOP. Therefore, those two right triangles can go into each other according to angle sine angle rule. We have those two angles, and the side that is included between those two angles in this green upper right triangle ZQO are corresponding equal to those two angles, and the side that is included between those two angles, that is side OP, in the green right triangle GOP. Therefore, those two right green triangles can go into each other according to angle sine angle rule. And from the fact that those two right green triangles can go into each other, we will derive that Their corresponding angles must also come to each other in their x. According to the rule that corresponding sides, their corresponding sides are equal to each other in their x. According to the rule that says that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore their corresponding sides must be also equal to each other in their x. The corresponding side of side ZQ is side GO. Why? Because both of them are located in front of this second 90 degrees minus alpha. And therefore, side ZQ, this upper rectangle equals to side GO in this upper lower green triangle. ZQ equals to GO. ZQ is x minus 1. So we can write down that ZQ equals to x minus 1. And from this equation, x minus 1 equals to ZQ equals to GO, we will derive that GO must be also equal to x minus 1 units in its length. This is side GO, this is equal to x minus 1 units in its length. Repeat again, because of the fact that those two right triangles can move to each other, their corresponding sides must be also equal to each other in their x. That is to say, ZQ must be equal to the corresponding side GO. Okay. So in the next step, we will implement the Pythagoras theorem on this right lower triangle, right green lower triangle, GOP. Here by PT, abbreviation for Pythagoras theorem. In this green right triangle GOP, according to the Pythagoras theorem, in a right triangle, the square of the opposite equals to the sum of the squares of the perpendicular. So in this green right lower triangle GOP, OP squared, this is the square of the opposite, equals to GO squared plus GP squared. And again, this right green lower triangle GOP, according to the Pythagoras theorem, OP squared, that is the square of the opponents, equals to GO squared plus GP squared. The opponent OP equals to x units in itself, therefore OP squared is x squared. And it equals to GO squared. GO is x minus 1, therefore GO squared is x minus 1 squared. Plus GP squared. GP is x minus 2, therefore GP squared is x minus 2 squared. So in total, we should find out that x squared equals to x minus 1 squared plus x minus 2 squared. Here we open the brackets on this side of this equation and find out that x squared equals to x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, this is 1, plus 2 times x minus 2 times x times 1, this is minus 2x, plus x minus 2 squared. X minus 2 squared equals to x squared plus 2 squared, this is 4, minus 2 times x times 2, this is minus 4x. So here we have x squared on both sides of this equation, so x squared gets cancelled. Also cancelled x squared. on this side of the equation we left with 0, that is to say, with nothing, that is to say 0. When on the other side of the equation we have 1 plus 4 is 5. We have minus 2x, minus 4x is minus 6x. And we have also x squared. So in total we found out that x squared minus 6x plus 5 equals to 0. So okay, this is the quadratic equation. And the general formula for quadratic equation is as follows. Ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation. And x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in our specific quadratic equation, that is to say x squared minus 6x plus 5 equals to 0. The variable that we're looking for is x, and x is the radius of this semicircle. The coefficient a in our specific quadratic equation is 1. So, x is the radius of the semicircle. That is the variable that we are looking for in this quadratic equation. X is the radius of the semicircle. The coefficient a equals to 1 unit in itself, the coefficient b equals to 160, the coefficient a equals to 1, the coefficient b equals to minus 6, and finally the coefficient c equals to 5. So we have all the data that is needed in order to find out the variable that we're looking for in our specific quadratic equation. This is x, and x is the radius of the semicircle. You just have to put the data inside the general formula for x. It is actually x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we just have to put the data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of x, because x might have two solutions. So we do it now and get that x equals to minus b. b is minus 6, so minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, and therefore b squared is minus 6 squared, that is 36, minus 4 times a times c. So it is minus 4 times a. A is also minus 4 times 1 is minus 4 times c. C is 5, so minus 4 times 5 is minus 20. So in total, minus 4 times a times c is minus 20. So inside the root we have 36 minus 20 over 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we found out that x equals to 6 plus minus. Inside the root we have 36 minus 20, that is 16. So inside root we have only 16 over 2. So x equals to 6 plus minus, the square root of 16 is 4 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 6 plus 4 over 2. 6 plus 4 is 10, and 10 over 2 is 5. So the first solution for x is x equals to 5. That is to say, the radius of the semicircle x equals to 5 units in its length. The other solution for x is as follows. X equals to 6 minus 4 over 2. 6 minus 4 is 2, and 2 over 2 is 1. So the second solution for x is that x equals to 1 unit in its length. That is to say, the radius of the semicircle x equals to 1 unit in its length. This is line 7 GP is equals to x minus 2 according to what we have already found out. The value of line 7 GP is x minus 2. And if x equals to 1, it means that x minus 2 is 1 minus 2, that is minus 1. So GP equals to minus 1. Because of the fact that GP is a left, GP as a left must be a positive number. Therefore, GP can never be equal to minus 1, that is a negative number. Must be a positive number. Another way to prove that x can never be equal to 1 is because of the fact that GP equals to x minus 2. We already found out that GP equals to x minus 2 units in its length. GP is a left, so it's a left, it must be a positive number. That is to say, x minus 2 must be greater than 0. Here is the inequality that says that x minus 2 must be greater than 0. Here we add 2 to this inequality and get that x must be greater than 2. If x must be greater than 2, x can never be equal to 1 that is less than 2. There are two reasons that x can never be equal to 1. Therefore, the answer to this question is that the radius of this semicircle x equals to 5 units in its length. The radius of the semicircle, that is the radius that we are looking for this question, equals to 5 units in its length. That is the answer to the second question. So the next step, we summarize the lecture, which is to say, we repeat on the solution of the first question with the two methods, and then we repeat on the solution of this second question. In the first question, our test was to find out the area of this main shape. We found the area of this main shape by using two different methods. So in the domain, we have rectangle ABCD. we know that side AB of rectangle ABCD equals to 4 units in itself. This is line segment A8 is equals to 1 unit in itself. Inside this rectangle, we have this ring shape. This is angle BEC is equals to 45 degrees in size. Again, our test is to find out the area of this ring shape. The ring shape is actually triangle BEC, therefore our test is to find out the area of the triangle BEC. So repeat on the first method. First of all, ABCD is right angle, therefore all those four angles are right angles. We define the length of this line segment AD is x, so AD in total equals to 1 plus x. We also know that the opposite sides of a rectangle are equal to each other. That is to say, side AB equals to the opposite side DC. But AB is 3, therefore the opposite side DC must be also equal to 4 units in itself. Likewise, according to the sum rule, in the sum rectangle ABCD, side AD must be equal to the opposite side BC. But AD in total is 1 plus x, therefore the opposite side BC must be also equal to 1 plus x units in itself. In the next step, we did the construction, that is to say, from point E, we draw perpendicular on BC. Again, from point E, we draw perpendicular on side BC of rectangle ABCD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees inside according to the construction. We define the touching point of the perpendicular from point E and BC. This point is point M. By doing this construction, we get the small quadrangle AB and ME. Inside the small quadrangle AB and ME, we have 1, 2, 3 angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 face angle, total must be equal to 360 degrees, according to law that says that the sum of the angles in a quadrangle is equal to 360 degrees. Therefore, this 4 face angle must be equal to 9 degrees in size. So inside quadrangle AB and ME, we have 4 angles, so we can relate to quadrangle AB and ME is rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle AB and ME, side AB must be equal to the opposite side ME. But AB is 3, therefore the opposite side ME must be also equal to 4 units in itself. We define ME as h. This is a version from the height because it is the height to the base BC of the triangle BC. So BM equals to h equals to 4 units in itself. In the next step, we implement the Pythagoras theorem on this right upper triangle AEB. According to the Pythagoras theorem, in a right triangle, the square of the opponents equals to the sum of the squares for the perpendiculars. So in this right triangle AEB, EB squared, that is the square of the opponents, equals to AE squared plus AB squared. Repeat again. In the upper right triangle AEB, according to the Pythagoras theorem, BE squared, that is the square of the opponents, equals to AB squared plus AE squared. BE is the missing hypotenuse, so leave it as it is, and it equals to AB, it equals to AE squared plus AB squared. AE is 1, therefore E squared is 1 squared is 1 plus AB squared. AB is 3, so AB squared is 3 squared, that is 9. So total, if you found out that BE squared or AB squared doesn't matter, equals to 9 plus 1, that is 10. So BE squared equals to 10. If we to go to the equation, if we found out that the missing hypotenuse BE equals to the square root of 10 units in itself. This is the missing hypotenuse BE is equals to square root of 10 units in itself. The next time we implemented the Pythagoras theorem on this right lower triangle EDC. According to the Pythagoras theorem, in this right lower triangle EDC, EC squared, that is the square of the hypotenuse, equals to AD squared plus DC squared. And again, the right lower triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. EC is the missing hypotenuse, so leave it as it is. So it is EC squared equals to ED squared. ED is x, therefore ED squared is x squared plus DC squared. DC is 3, therefore DC squared is 3 squared, that is 9. So in total, we found out that EC squared equals to x squared plus 9. Here we took out all the equation, we found out the length of the missing hypotenuse EC equals to the square root of x squared plus 9. The hypotenuse EC equals to the square root of x squared plus 9. In the next step, we calculated the area of this green triangle ABC by using two different methods, and then we created the equation Let's say that the area of this green triangle BC according to the first model of calculation must be equal to the area of this green triangle BC according to the second model of calculation. According to the second model of calculation, the area of this triangle BC equals to the base BC times the height h over 2. And again, according to the first model of calculation, the area of the green triangle ABC equals to the base BC times the height h over 2. BC is x plus 1, h is 3. Then again, BC is x plus 1 and h is 3 divided by 2. So in total, we found out that the area of the green triangle BC according to the first model of calculation equals to x plus 1 times 3 over 2. The next step, we calculated the area of this green triangle BC in a different way, according to the new formula that I presented to you. This is triangle ABC that could be any triangle. Side AC equals to B incident step, side AB of this triangle ABC equals to A incident step. This is angle theta, this is the angle between those two sides A and B. According to the new formula, the area of this triangle ABC that could be any triangle equals to the multiplication of the two sides by each other. So say it is A plus A times B times the angle between the two sides, it is theta over 2. And again, the area of this triangle ABC that could be any triangle equals to A times B times sinus theta over 2. So we use the new formula in order to find out the area of this green triangle BEC. According to the new formula, the area of this green triangle BEC must be equal to BE times EC, the multiplication of the two sides of the triangle by each other, times sinus the angle between the two sides, that is sinus 45 degrees over 2. And again, according to the second method of calculation, the area of the green triangle BEC equals to EB times EC, that is the multiplication of the two sides by each other, times sinus the angle between the two sides, that is 45 degrees over 2. The next step, we created the question 3 that said that the area of triangle BEC according to the first method of calculation must be equal to the area of the triangle ABC according to the second method of calculation. The area of this green triangle ABC according to the first method of calculation equals to x plus 1 times 3 over 2. And it must be equal to the area of the green triangle BC according to the second method of calculation. The area of the green triangle BC according to the second method of calculation equals to EB times EC times sinus 45 degrees over 2. We have both sides of this equation. First of 2 we get cancelled, after we cancel 2. In this side of the equation we left only with x plus 1 times 3, while on the other side of this equation we left with EB times EC, and sinus 45 degrees is square root of 2 over 2. So here we have x plus 1 times 3 equals to EB times EC times square root of 2 over 2. Also 3 times x plus 1 equals to the square root of 2 times x. Actually, EB equals to the square root of 10 and EC equals to the square root of x squared plus 9 times square root of 2 over 2. So 3 times x plus 1 equals to the square root of 10 times the square root of 2 is the square root of 20 times square root of x squared plus 9 over 2. Here we substitute 20 by 4 times 5, so inside the root we have 4 times 5. So in total we should find out that 3 times, according to equation 3 times x plus 1 equals to 20 is 4 times 5, so it is the square root of 4 times 5 times the square root of x squared plus 9 over 2. The square root of 4 is 2, so took 4 out of the root, so inside the root we left only 5. So in total we found out that according to equation 3 times x plus 1 equals to the square root of 4 is 2, so inside the root we left only with square root of 5 times the square root of x squared plus 9 divided by 2. We have 2 in the numerator, 2 in the denominator, so 2 get cancelled, so cancel 2. We found out that 3 times x plus 1 equals to the square root of 5 times the square root of x squared plus 9 Here we squared both sides of this equation, equation 3. So 3 times x plus 1 squared equals to 3 squared is 9 times x plus 1 squared. And the square root of 5 squared is 5. And the square root of x squared plus 9 equals to x squared plus 9 because of the fact that the square cancels the root and the left only x squared plus 9. So in total, according to equation 3, we found out that 9 times x plus 1 squared equals to 5 times x squared plus 9. So it is 9 times x plus 1 squared. X plus 1 squared equals to x squared, plus 1 squared is 9, plus 2 times x times 1 that is 2x, and it equals to 5 times x squared is 5x squared, plus 5 times 9 is 45. So in total, according to equation 3, we found out that 9 times x plus 1 plus 1 plus 2x equals to 5x squared plus 45. Here we open the bracket of this side of this equation, equation 3, we found out that according to equation 3, 9 times x squared equals to 9x squared, plus 9 times 4 is 9, plus 9 times 2x is 18x, and it equals to 5x squared plus 45. Here we substitute 5x squared for this equation, equation 3, and we found out that 9x squared minus 5x squared is 4x squared, and we have plus 9 plus 18x equals to 45. Here we substitute 45 for this equation, equation 3, and we actually found out that according to this equation, equation 3, 4x squared plus 18x, and 9 minus 45 is minus 36 equals to 0. Here we divided this equation, equation 3 by 4, and finally found out that 4x squared over 4 is x squared, 18x over 4 is 4.5x, and minus 46 over 4 is minus 9, and it equals to 0 over 4 is 0. So in total we found out that x squared plus 4.5x minus 9 equals to 0. So this is the quadratic equation, and the general formula for quadratic equation is as follows: ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus 4 of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 4.5x minus 9 equals to 0, the variable that we are looking for is x. X is the left of this answer and AD. The coefficient A equals to 1, the coefficient B equals to 4.5, and the coefficient C equals to minus 9. So the only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x, and this way we find out the value of the values of x. X is the left of this answer and AD. So if we did it, and if we found out that x equals to minus b, b is 4.5, therefore minus b is minus 4.5, plus minus square root of b squared, b is 4.5, and therefore b squared is 4.5 squared is 20.25, minus 4 times a times c. A is 1, so minus 4 times a is minus 4 times 1, that is minus 4 times c. C is minus 9, so minus 4 times minus 9 is plus 36. So total minus 4 times a times c is plus 36. So inside the root we have 20.25 plus 36 divided by 2a. A is also 2a is 2 times 1, that is 2. So in total we found out that x equals to minus 4.5 plus minus 20.25 plus 36 is 56.25 over 2. The square root of 56.25 is 7.5. So in total we found out that x equals to minus 4.5 plus minus 7.5 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 4.5 minus 7.5 over 2. Minus 4.5 minus 7.5 is minus 12, and minus 12 over 2 is minus 6. So according to the first, the value of x according, we have two solutions for x. So the value of x according is x equals to minus 6. And because of the fact that x is the left of this answer ED, x is the left, it must be a positive number, so x can never be equal to minus 6. It's a negative number. And the second solution for x is as follows: x equals to minus 4.5 plus 7.5 over 2. Minus 4.5 plus 7.5 is 3, so in total x equals to 3 over 2, that is 1.5. If we found out the left of this answer and ED is equals to x is equals to 1.5 minutes in itself. Our test is to find out the area of this green shape. The area of this green shape is the area of this green triangle ABC. because of the fact that the green shape is a triangle, actually we have to find out the area of the great triangle ABC. The area of the great triangle ABC equals to the base of the triangle times the height over 2. We choose the base as BC and the height is edge over 2. So the base is BC, the height is edge over 2. BC is 1 plus x times the height, that is 3 over 2. X is 1.5, therefore 1 plus x is 1.5 plus 1, that is 2.5 times 3 over 2. 2.5 times 3 is 7.5 and 7.5 over 2 is 3.75 squares in size. So we found out that the area that we are looking for in this question, that is the area of this green shape, in total it is equal to 3.75 squares in size. We finish to repeat on the first method, and next step repeat on the solution according to the second method. The second method, first of all, because of the fact that ABCD is rectangle, all those triangles are right angles. We define the length of right side ED as x, so first of all, the opposite sides of rectangle are equal to each other. So in rectangle ABCD, side AB must be equal to the opposite side DC, but AB is 3, therefore the opposite side DC must be also equal to 3 in its length. Likewise, according to the same rule, in the same rectangle ABCD, side AD must be equal to the opposite side BC, but AD in total is 1 plus x, therefore the opposite side BC must be also equal to 1 plus x units in its length. In the next step we did the construction, that is to say from point A we took a perpendicular on BC. So this angle plus 180 and this angle also plus 180 according to our construction. We define the touching point of the perpendicular from point E and BC, this point is point M. By doing this construction, we can add the small quadrilateral AB and E. Inside the small quadrilateral AB and E, we have 1, 2 triangles. Therefore, this four piece area must be equal to 90 degrees in size, according to the rule that says that the sum of the area in quadrilateral is equal to 360 degrees. So in quadrilateral AB and E, we have 4 degrees, and therefore can relate to quadrilateral AB and E is rectangle. But we also know that the opposite sides of rectangle to each other. The opposite sides of rectangle are equal to each other. So in the small rectangle AB and E, side AB must be equal to the opposite side ME. But AB is 3, therefore the opposite side ME must be also equal to 4 units in its length. We define ME as h, so ME equals to h equals to 3. In the next step, we define this angle AEB as theta. So in that time AEB, tan theta equals to AEB over AE. Again, in this right triangle AEB, tan theta equals to AEB over AE. In the upper right triangle AEB, tan theta equals to AEB over AE. AEB is 3, AE is 1. So in total, tan theta equals to 3 over 1, that is 3. So tan theta equals to 3, according to equation 1. We have a trigonometric identity that says that tan 45 degrees plus theta equals to 1 plus tan theta over 1 minus tan theta. So we define the trigonometric identity as equation 2, and we found out that tan theta equals to 3, so we can substitute tan theta in this trigonometric identity by 3. So we did it, we found out that tan theta plus 45 degrees equals to 1 plus tan theta, that is 3, over 1 minus tan theta, that is 3. So total tan theta plus 45 degrees equals to 1 plus 3, that is 4, over 1 minus 3, that is minus 2. 4 over minus 2 is minus 2. So in total, we found out that according to equation 2, tan 45 degrees plus theta equals to minus 2. And according to equation 1, we only found out that tan theta equals to 3. AD is one side of rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side of the straight line AD at point D, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AD at point D? We have this angle that is theta, plus this angle that equals to 45 degrees in size, plus this missing angle that is actually angle DEC in total must be equal to 180 degrees according to rule 3. Repeat again, in the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line AD at point E? We have theta plus 45 degrees plus the size of the third missing angle, that is angle DC in total must be equal to 180 degrees according to rule 3. So we subtract theta plus 45 degrees from this equation. We found out that the missing angle DEC must be equal to 180 degrees minus theta plus 45 degrees. So this is the missing angle DEC is equal to 180 degrees minus theta plus 45 degrees. The next step we focus on this right quadrant and EDC. According to in this right quadrant and EDC, targets 180 degrees minus theta plus 45 degrees is equal to DEC over DE. And again, the right side DC targets 180 degrees minus theta plus 45 degrees is equal to DC minus AD. DC is 3, ED is X. So in total, targets theta targets 180 degrees minus theta plus targets 180 degrees minus theta plus 45 degrees equals to 3 over X. So this is equation 3 that said that targets 180 degrees minus theta plus 45 degrees equals to 3 over X. We have the trigonometric identity that said that targets 180 degrees minus theta equals to minus target theta. According to this trigonometric identity, we get that targets 180 degrees minus theta plus 45 degrees must be equal to minus theta minus targets theta plus 45 degrees. And therefore, we can substitute targets 180 degrees minus theta plus 45 degrees by minus targets theta plus minus targets theta plus 45 degrees. We did it, and we found out that according to equation 3, again, targets 180 degrees minus theta plus 45 degrees equals to minus targets theta plus 45 degrees according to this trigonometric identity, and it is equals to 3 over X. But we already found out that according to equation 2, target theta plus 45 degrees equals to minus 2. So we can substitute minus target theta plus 45 degrees minus 2, and we have another minus, we have copied here, so on this side of the equation we have minus 2, this is equals to 3 over X. Minus times minus is 2, so total this side of equation 3 we have 2, this is equals to 3 over X. Here we multiply this equation 3 by 2, and we found out that 2x equals to 3. Here we divided this equation 3 by 2, and we found out that x equals to 3 over 3 halves, that is 1.5. So again, x equals to 1.5, and it's in its term. Our test is to find out the area of this green shape. The green shape is actually triangle BEC. So we have to find out the area of this green triangle BEC. The area of the green triangle BEC equals to the base BC times the edge over 2. And again, our test is to find out the area of the green shape, but the green shape is the green triangle BC, so our test is to find out the area of the green triangle BC. The area of the green triangle BC equals to the base BC times the edge over 2. BC is x plus 1, edge is 3. So BC is x plus 1 and edge is 3. So in total, the area of the green shape equals to x plus 1 times 3 over 2. X is 1.5, therefore x plus 1 is 1.5 plus 1, that is 2.5 times 3 over 2. 2.5 times 3 is 7.5, and 7.5 over 2 is 3.75, so it's in size. So in both methods, we have found out that the area that we're looking for this question, that is the area of this green shape, EBC equals to 3.75, so it's in size. We finish with the first question. In the next step, I put on the solution of the second question. In the second question, our test will find out the radius of this semicircle that is described by rectangle ABCD. So in the drawing, we have rectangle ABCD that blocks this semicircle, or this semicircle is described by rectangle ABCD. This is 97 cubic, is equals to 1 unit in its length. This is 97 PD, is equals to 2 units in its length. Again, our test is to find out the radius of this semicircle. First of all, ABCD is a rectangle, therefore all those four sides are right angles. And we define the center of this semicircle, this point O. We define the radius of this semicircle as x. The radius of the semicircle equals to x. we define the point of tendency of tangent DC with this semicircle, this point is point T. Likewise, we define the point of tendency of tangent BC with this semicircle, this point is point L. The next step, we join points O and together by straight line. Point O is the center of the semicircle, point T is the point of the semicircle itself, therefore T is the radius of the semicircle equals to X. The radius of T is equal to X, the radius of T is drawn to point T, this is the point of tendency of tangent DC with this semicircle. And whenever your radius is drawn to the point of tendency, then tangent DC will be perpendicular to the radius TO. If TC is perpendicular to TO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. According to all 1. And this angle equals to 90 degrees, and this angle also equals to 90 degrees according to all 1. In the next step, we join points O and L together by straight line. Point O is the center of the semicircle, point L is the point of the semicircle itself, therefore O is the radius of the semicircle is equal to X. The radius of L is equal to X, the radius of L is drawn to point L, that is the point of tendency of tangent BC with this semicircle. And now your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius LO. If BC is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule on 1. So in the lower small quadrangle or LCT, we have 1, 2 furthers. The sum of right degrees is 270 degrees, so 270 degrees plus the size of this 4 pieces, and so that must be equal to 360 degrees. According to the rule that says that the sum of the areas in any quadrangle is equal to 360 degrees. And therefore, this 4 pieces must be equal to 90 degrees inside. So inside quadrangle or LCT, we have 4 degrees, and therefore, to quadrangle or LCT is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So rectangle or LCT, side OL must be equal to the opposite side TC. But OL is X, therefore the opposite side TC must be also equal to X units in itself. Likewise, according to the sum rule, the sum rectangle or LCT, side OT must be equal to the opposite side LC. But OT is X, therefore the opposite side LC must be also equal to X units in itself. So in total, we found out that quadrangle or LCT is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other, its side equals to X. In the next step, we do the construction. That is to say, from point O, that is the center of the semicircle, we go perpendicular on AB. Again, from point O, we go perpendicular on side AB, of rectangle ABCD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. By doing this construction, we get that the upper quadrangle is ZBLO. Inside the upper quadrangle ZBLO, we have 1, 2 furthers, and therefore this 4 pieces must be equal to 90 degrees inside according to the sum rule. That says that the sum of the areas in the quadrangle is equal to 360 degrees. So in quadrangle ZBLO, we have 4 degrees, therefore we can add to this quadrangle ZBLO is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So rectangle ZBLO, side OL must be equal to the opposite side ZB. But OL is X, therefore the opposite side ZB must be also equal to X units in its length. What is the length of this short line, of this line segment ZQ? ZQ equals to ZB minus QB. Again, ZQ equals to ZB minus QB. So ZQ equals to ZB, that is X, minus QB, that is 1. So in total, ZQ equals to X minus 1 units in its length. By doing this construction, we created another quadrangle. This is quadrangle AZ, but before that, we did another construction. That is to say, from point O, we go perpendicular on AD. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the construction. We define the touching point of the perpendicular from point O and AD. This point is point G. By doing this construction, we created the upper quadrangle AZ OG. Inside the upper quadrangle AZ OG, we have 1, 2 furthers, and therefore this 4 pieces must be equal to 90 degrees in size. And therefore, a quadrangle AZ OG that is 4 degrees is a rectangle. Okay. By doing this construction, we get the lower quadrangle GOTD. Inside this quadrangle GOTD, we have 1, 2 furthers, and therefore this 4 pieces must be equal to 90 degrees inside, and therefore quadrangle GOTD, that is 4 right angles, it is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the lower rectangle GOTD, side OT must be equal to the opposite side GD. But OT is X, therefore the opposite side GD must be also equal to X units in its length. What is the length of this missing line segment GP? GP equals to GD minus PD. Again, GP equals to GD minus PD. So GP equals to GD, this is X, minus PD, this is 2. So in total, the missing line segment GP equals to X minus 2 units in its length. This is the big angle GOL. The big angle GOL equals to 90 degrees plus 90 degrees, this is 180 degrees. And you know that any angle is equal to 180 degrees in inside, it is defined as a straight line. Because of the fact that angle GOL is equal to 180 degrees in inside, line segment GOL must be equal to a straight line. Must be a straight line. If GOL is a straight line, then GL is also a straight line. And therefore this is shape ABLG, that is 4 sides. 1, 2, 3, 4. Shape ABLG is 4 sides. And therefore shape ABLG is a quadrilateral. Again, shape ABLG is a quadrilateral because it has 4 sides. But in quadrilateral ABLG, we have 4 right angles, and therefore quadrilateral ABLG must be a rectangle. Because of the fact that quadrilateral ABLG is 4 right angles, it must be a rectangle. But you also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABLG, side AB must be equal to the opposite side LG. So here, you can implement rule 10. You can implement rule 10 because of the fact that side AB equals to side GL. We have those 2 angles that are defined as corresponding angles and are located between the parallels AB and GL, therefore they must be equal to each other in their sizes. Repeat again on rule 10 according to rule 10. Repeat again on rule 10 according to rule 10. Corresponding angles between parallels are equal to each other. So in the drawing we have line A that is parallel to line B. There is line C is transversal that cuts those 2 parallels A and B in those 2 points. Those 2 angles are defined as corresponding angles and are located between the parallels A and B, therefore they must be equal to each other in their sizes. Each of them is equal to 1, therefore they are equal to each other. Likewise, those 2 angles are also defined as corresponding angles and are located between the parallels A and B, therefore they must be equal to each other in their sizes. Each of them is equal to 2, therefore they are equal to each other. So according to this rule 10, corresponding angles between parallels are equal to each other. So as we mentioned before, we can implement rule 10 in our drawing. Why? Because in our drawing, those 2 angles are defined as corresponding angles and are located between the parallels AB and GL. And again, we already found out that AB is parallel to GL. AB is parallel to GL. And because of the fact that those 2 corresponding angles are located between the parallels AB and GL, they must be equal to each other in their sizes. So if the size of this angle is alpha, then the size of this angle must be also equal to alpha because they are equal to each other according to rule 2, to rule 10. So in the upper right triangle ZQO, this angle equals to alpha, this angle equals to 90 degrees, and therefore this part, this angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in a triangle. Likewise, in the lower right triangle QOP, this angle equals to alpha, this angle equals to 90 degrees, and so this first missing angle must be equal to 90 degrees minus alpha according to the sum rule that says that the sum of the angles in a triangle is equal to 180 degrees. In the next step, to prove that those 2 green right angles can go into each other according to side angle rule. So why those 2 green right angles can go into each other? First of all, those 2 angles are both equal to alpha and therefore they are equal to each other. In addition, OQ equals to OP, they are both the radii of the semicircle and therefore they are equal to each other. And finally, those 2 angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. Therefore, those 2 right angles can go into each other according to side angle rule. And again, we should find out that the right upper triangle ZOQ congruent, this is the sign of congruent, to the right lower green triangle OGP according to side angle rule. That is to say that we found out that those triangles and the side that is included between those triangles that is side QO and this upper triangle ZOQ corresponding equal to those triangles and the side that is included between those triangles that is side OP. This right lower triangle, triangle GOP. Therefore, those two right triangles can go into each other according to side angle rule. And from the fact that those two right triangles can go into each other, we know that their corresponding sides must be also equal to each other in their lengths. That is to say, side ZQ is equal to its corresponding side GO. Why ZQ is the corresponding side of GO? Because of the fact that both those two sides are located between this angle that is 90 degrees minus 1 So ZQ equals to the corresponding side GO. ZQ equals to GO. But we already found out that ZQ equals to x minus 1, so we can write that ZQ equals to x minus 1, and from this equation x minus 1 equals to ZQ equals to GO, we derive that GO must be also equal to x minus 1 units in its length. This is the missing side GO, this is equal to x minus 1 units in its length. We already found out that GP equals to x minus 2, and the opponent's BO of the green triangle PGO is x. The next step, we implemented the Pythagoras theorem on this green right lower triangle, triangle GOP. According to the Pythagoras theorem, in any triangle, the square of the opponents equals to the sum of the source of the perpendiculars. So in this right triangle GOP, OP squared is the square of the opponents equals to GO squared plus GP squared. See again, in the right green triangle GOP, according to the Pythagoras theorem, OP squared is the square of the opponents equals to GO squared plus GP squared. OP is x, therefore OP squared is x squared, and it is equals to GO squared. GO is x minus 1, therefore GO squared is x minus 1 squared, plus GP squared. GP is x minus 2, therefore GP squared is x minus 2 squared. So in total, we should find out that x squared equals to x minus 1 squared plus x minus 2 squared. So x squared equals to, we open the bracket on this side of this equation, so x squared equals to x minus 1 squared. X minus 1 squared equals to x squared, plus 1 squared is 1. Minus 2 times x times 2, this is minus 2x, plus x minus 2 squared. X minus 2 squared equals to x squared, plus 2 squared, this is 4, minus 2 times x times 2, this is minus 4x. So we have x squared on both sides of this equation, so x squared we get cancelled. After cancelled x squared on this side of the equation, we have nothing, that is to say 0, 0, and on the other side of the equation, we have 1 plus 4 is 5, minus 2x minus 4x is minus 6x. Plus x squared. So in total, we should find out that 0 equals to 5 minus 6x plus x squared. Again, x squared minus 6x plus 5 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus 4 to p squared minus 4 times a times c over 2a. Now a specific quadratic equation, this is to say a squared on 6x plus 5 equals to 0, the variable that we are looking for is x. And x is the radius of this semicircle. The coefficient a equals to 1, the coefficient b equals to minus 6, and the coefficient c equals to 5. The only thing that is have to do is to put the data of our specific quadratic equation inside this general formula for x. In this way we find out the value of the values of x. Because x might have two solutions, and x is the radius of this semicircle. So we did it, and we found out that x equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, so b squared is minus 6 squared, that is 36, minus 4 times a times c. So it is minus 4 times a. A is minus 4 times 1 is minus 4 times c. C is minus 6, so minus 4 times minus 6 is c is 5, so minus 4 times 5 is minus 20. So in total, inside the root, we have 36 minus 20 over 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in total, we have found out that x equals to 6 plus minus. 36 minus 20 is 16, so inside the root, we left only 16 over 2. So x equals to 6 plus minus. The square root of 16 is 4 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 2 is 5. So According to the first solution for x, that is the radius of this semicircle equals to 5 units in its length. We have another solution for x. The second solution for x is as follows. X equals to 6 minus 4 over 2. 6 minus 4 is 2 and 2 over 2 is 1. So according to the first solution for x, that is the radius of this semicircle equals to 1 unit in its length. But x can never be equal to 1. Why? Because of the fact that this is 97 GP is equal to x minus 2. GP equals to x minus 2, so if x equals to 1, then x minus 2 is 1 minus 2, then minus 1. And because of the fact that GP is a length, GP can never be equal to minus 1, it must be a positive number. Another reason that x can never be equal to 1, because of the fact that GP equals to x minus 2. GP equals to x minus 2. GP is a length. GP is a length, it must be a positive number. That is to say, it must be greater than 0. So we have the inequality that says that x minus 2 equals greater than 0. Here we added 2 to this inequality and we found out that x greater than 0. X must be greater than 0. If x must be greater than 0, x can never be equal to 1. That, again, x minus 2 equals to 0. We added 2 to this inequality and we found out that x must be greater than 2. If x must be greater than 2, then x can never be equal to 1, that is less than 2. So we have two reasons that x can never be equal to 1. Therefore, we left only the other solution for x, that is x equals to 5 units in its length. We found out that the radius of this semicircle, that is the radius that we are looking for in this question, is equal to 5 units in its length. Okay, thank you very much.